Mars has long been a world of mystery, a quiet, distant desert that has inspired storytellers, scientists, and explorers for centuries. To the naked eye, Mars shines with an unmistakable reddish glow, earning it a title, the Red Planet. Today, Mars remains one of the most studied worlds in our solar system, not only because it resembles Earth in subtle ways, but because it holds clues to our own past and perhaps even our future. Mars formed billions of years ago from the same swirling disk of gas and dust that built the Sun and planets. Smaller than Earth, with less gravity and less internal heat, the planet cooled more quickly. Early in its life, Mars may have been very different from the cold desert we see today. Evidence suggests that its surface once held liquid water, flowing rivers, open lakes, and possibly even shallow oceans. Features that look like dried riverbeds, mineral deposits, and ancient shorelines hint at a warmer, thicker atmosphere that could have protected liquid water on the ground. Mars holds the memory of a world that may once have been far more alive than it is now. Some of the most striking landmarks in the solar system are found on Mars. Olympus Mons towers higher than any mountain on Earth. A gigantic shield volcano rising about 25 kilometers above the surrounding plains. Nearby lies Valles Marineris, a canyon system that stretches across nearly a quarter of the planet's circumference, deeper and longer than any canyon on our world. The surface is dotted with impact craters, dark basaltic plains, and dunes sculpted by wind. Each feature on Mars is a chapter of its geologic story, preserved in the thin air and frozen landscapes. Mars is smaller than Earth, with just over half our planet's diameter and only about 1/10 of its mass. Its weaker gravity, roughly 38% of Earth's, means that objects fall more slowly and that materials behave differently than they do here. Gravity this low also makes it harder for Mars to hold a thick atmosphere. On average, Mars orbits the Sun at a distance of about 228 million kilometers, nearly 1.5 times farther out than Earth. When Earth and Mars happen to be closest in their orbits, the two worlds come within about 55 million kilometers, but at their most distant, they sit on opposite sides of the Sun, separated by hundreds of millions of kilometers. Beneath the red plains, Mars has a crust, a rocky mantle, and a small core that may still be partly molten, though far smaller and less active than Earth's. Its cooling interior and weak magnetic remnants help explain why Mars lost most of its atmosphere over time, transforming from a once warmer, wetter world into the cold, dry desert we see today. Unlike Earth, Mars no longer has a strong global magnetic field. Without that shield, the planet's thin carbon dioxide atmosphere was slowly stripped away by solar radiation and the solar wind. What remains is fragile and unable to trap much heat. Temperatures vary wildly. In the warmest regions and hours of the Martian day, they might climb to a few degrees above freezing, but by night or at higher elevations, they can plunge below -100 degrees Celsius. Winters near the poles can fall even lower. These harsh swings, combined with low pressure and intense radiation, create an environment that is both fascinating and unforgiving. The skies of Mars are shaped by dust. Fine grains of iron-rich soil color the atmosphere, scattering sunlight into soft oranges and reds. Winds can sweep this dust into local whirlwinds or into massive storms that grow until they encircle the entire planet. When this happens, the sun above becomes dim and hazy. Sunsets on Mars glow blue as the dust scatters red light and lets the cooler wavelengths pass through. The familiar red soil itself is the result of iron minerals weathering over time into iron oxide, rust, a simple process that over billions of years gave Mars its distinct color. Mars also shares surprising rhythms with Earth. Its day lasts just over 24 hours, making its sunrises and sunsets familiar in pace. The planet is tilted on its axis much like Earth, so it experiences seasons. As sunlight shifts, temperatures change, polar caps grow and retreat, and frost settles onto the ground. Summers are milder, but still frigid by our standards, while winters can be deep and bitter. These cycles hint at a world that once might have been more dynamic, shaped by sunlight, climate, and shifting ice, a quieter reflection of patterns we know on our own world. Orbiters and rovers have uncovered powerful evidence that Mars once had conditions suitable for water. Valley networks that resemble river systems, sediments laid down by flowing streams, minerals there that form only in liquid water, and deposits that look like ancient shorelines. Instruments have also found ice beneath the surface, and signs that underground pockets may still hold traces of moisture. The search continues, pushing deeper into the crust and deeper into chemical signatures, looking for hints of ancient or even microscopic life. Mars has two tiny moons, Phobos and Deimos. Both are irregular, asteroid-shaped bodies captured long ago. Phobos orbits so close to Mars that tidal forces are slowly pulling it inward. In tens of millions of years, it may fracture or break apart, scattering debris in orbit. Deimos is smaller and more distant, circling quietly at the edge of Mars' gravity. These moons are reminders of how dynamic planetary systems can be, shaped by collisions, captures, and slow changes over time. Exploration of Mars has been one of humanity's most persistent scientific efforts. Dozens of spacecraft have studied the planet from orbit, mapping its surface in high detail, scanning its minerals, measuring its atmosphere, and watching its seasons unfold. On the ground, rovers such as Spirit, Opportunity, Curiosity, and Perseverance have rolled across the terrain, drilling into rocks, sampling soil, and analyzing ancient sediments that may preserve the chemistry of old lakes and rivers. Each mission adds another piece to the story of a world that once might have been warm, watery, and more welcoming. Part of the reason Mars is so compelling is that it resembles Earth in unexpected ways. Its length of day, its seasons, traces of past water, and hints of underground ice all point to a world that was not always as barren as it is now. Deep in its history, thick atmospheres, magnetic fields, and large bodies of water may have shaped its surface. Discovering how Mars changed helps us understand how planets evolve, and why Earth stayed habitable while others did not. Mars also raises questions that reach beyond geology. If the planet once had liquid water, warmth, and thick air, could microbial life have formed there? Could it exist now, hidden deep below the surface, protected from radiation and extreme cold? Some orbiters and rovers have detected methane in the atmosphere, a gas that can be produced chemically or by biological activity. Scientists continue to study these traces carefully, hoping to uncover whether life ever took hold on the red planet. Human exploration of Mars has long been imagined, and plans are moving slowly from idea to engineering. The biggest challenges are severe: thin atmosphere, freezing temperatures, toxic soil chemistry, low gravity, and constant radiation from the sun and deep space. Without a strong magnetic field or thick air, Mars offers little protection. Any long-term presence would require shielding, sustainable habitats, and careful use of local resources. Some researchers have proposed ways that Mars could be gradually warmed or its atmosphere thickened over centuries, but these ideas are still theoretical, glimpses into what might someday be possible, but not close to reality today. Yet Mars remains our most realistic destination beyond the Moon. Its soil holds water in the form of ice. Its length of day is familiar. Its surface gravity, though weaker, is not impossibly low for construction and movement. And every mission teaches us more about how to live and work far from Earth. For scientists, Mars is a test bed, a place to learn how worlds change, how atmospheres are lost, and what ingredients a planet may need to support life. Mars matters because it helps us understand Earth. It shows us what happens when a planet cools, loses its magnetic field, and surrenders its atmosphere to space. It preserves ancient landscapes that Earth has erased with wind, water, and tectonic change. And it stands as a reminder that our solar system once held many possibilities. That Earth is not alone in having oceans, ice, clouds, and great storms. Somewhere on Mars, the past is etched into dried river channels, silent volcanoes, and scars left by dust and time. We look toward this quiet red world not only to learn about its nature, but to understand ourselves, about the fragile balance that makes a planet habitable, and the thin line between life and lifeless stone. Thank you for watching. Do not forget to share your thoughts in the comments. I hope to see you in the next video.